All right, as you might be able to see here, I'm sitting down near one of my workbenches down in my basement. And over here on my bench, I have a box of drill bits. Oh, box of drill bits right there. All right. Now, what I'm interested in is what are these drill bits made out of? What kind of metal is this drill bit made out of? Now, if you look at the color and try to figure out what it's made of just based on its color, you're not going to help yourself out at all. They put special coatings on the outsides of a lot of these drill bits to help them maintain their sharpness for a longer period of time. It's a hardened coating. I think there's some kind of what's called a nitride coating on this. Let's see. All right. They're called cobalt drill bits, but I don't believe they're made out of the pure metal cobalt. Let's see if we can't figure out. It's probably some type of tool steel, as it's called. Steel is an alloy containing mostly iron. But let's see what we could do with this. Based solely on its density, let's see if we can't figure out exactly what type of steel alloy this particular drill bit is made out of. All right. Now, to get the density of any material, you need the mass of that object and its volume. Now, mass is simple enough. All we need is a balance. So let's do that right now. All right, put our balance down here on the workbench. Zero it out. All right, it's reading 0. And we'll put this drill bit right on there. And the mass of this drill bit is 72.40 grams. All right. So that's the easy part. All right. If you could read that, 72.40 grams is for the drill bit. Let's drill bit. Okay. Now, the real issue with this guy here is how do we determine its volume? All right. It isn't a liquid. We can't just pour it into a graduated cylinder and read the numbers up the side. All right. Nor is it a shape that makes it easy to compute volume. You know, if the drill bit were shaped like a cube, then I could do length times width times height, but you can't do that with the drill bit. So how do we determine the volume of a solid material that doesn't have a nice, simple geometric shape? Well, it's a method called water displacement. With water displacement, we do utilize a graduated cylinder. All right. And how this works is we're going to go ahead and pour some water in this graduated cylinder. And we want to make it deep enough so that when we put the drill bit in, the drill bit is going to be completely submerged. So let's see. It looks to me like it's right up around the 70 milliliter or 70 cubic centimeter line. So if we fill it up to about 70 with water, I think we'll be in good shape. So let me see if I can do this with one hand on the camera and one hand pouring the water. All right, so let's put some water in the graduated cylinder and we'll fill it up to about 70. Now, it doesn't have to be exactly on 70. As a matter of fact, I stopped just somewhere near 70. The important thing now is to make sure we read the value on here, and I'm going to put a piece of white paper behind it to make things a little bit easier. All right. Now, I can't easily read this while trying to hold the camera, and also I'm going to just stop this a second, and I'm going to put a little explanation on the video on how we take a reading of this measurement. All right. Now, at this stage of the game, get that out of the way. What we're going to do is we're going to put this drill bit down into the water. All right. When it goes into the water, it's going to displace or move out of the way a certain amount of the water. And the only place for the water to go is up inside the graduated cylinder. And when we submerge this completely, the amount of volume that the water increases to is exactly equal to the volume of the object that's in the graduated cylinder. So what we're going to do is slip it in and then take another volume reading. And give me a second. But you got to be careful here. If you just drop the drill bit in and it falls quickly into the bottom, it's going to smash this thing. So we got to be really careful. See if I can figure this out here. Hold on. And put you guys above here. Okay. Here's what I'm going to do. Is I'm going to take this graduated cylinder and just tilt it over sideways, and that way I could allow this drill bit to very slowly fall to the bottom of the graduated cylinder. And now, see, I've got the drill bit in there. Let's see if I can zoom into that. All right. The drill bit is completely submerged. There's the top of the drill bit right there, but the water level is above it. It has to be completely submerged, otherwise this method of measuring volume won't work. This method is called water displacement method. All right. If I put this little piece of paper behind it and take a close look at where the level of the water falls in regards to all those little lines. Let's see. In regards to all those little lines that you see going up and down the graduated cylinder. Right, we got to read those lines. Again, it's going to be hard for me to, while I'm trying to take the video, to read these properly, but I will stop the video and I'll put something up on the video screen concerning the volume. Now, getting back to the formula, the volume by water displacement we get by subtracting the two volume readings we took off the graduated cylinder. We take the final reading, the volume with the drill bit in the water, and we subtract from it the volume of the water that was in the graduated cylinder when it was just the water. There was no drill bit. We subtract those two, and that'll give you the volume. Right. Once we get that, just do this division and get the density. The mass, 72.40, divided by whatever we get for the volume by water displacement. And that'll give us a density of the steel alloy that these particular drill bits are made out of. Right, now, besides getting the density, I'm going to go ahead and put up some the values of some densities of some common steel alloys that are used in the making of tools, especially cutting tools like drill bits. And what I'd like you to do is try to track down exactly what type of tool steel alloy these drill bits may be made out of.